Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we'll be learning today in control system is going to be compensators and controllers. This is one of the most important concept in control system. It's a little theoretical concept. There are also analytical things in this. So I'm going to teach you about this. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. The links are given down in the description box. All the summary video, short videos, the formula pages are uploaded regularly on my Instagram page. You can please check out on that page and follow me over there as well. The links are given down in the description box. So let's begin up with compensators and controllers. So first to begin with, we'll begin with compensators. So what are compensators? Compensators in control system is a component that is used to regulate another control system. So as I told you, compensator is a part of control system and it is used to regulate some another control system. In order to make the system behave as desired, it is necessary to redesign the system and a compensator to compensate for the same. So you have a particular system and you need to redesign it. You need to make certain changes in that so that it is giving you a desired operation. So in that case, certain compensators need to be added for that. So compensators are basically components in a control system that are basically used in order to make the system efficient and to make certain redesigning in it. And if you want to redesign the system, certain compensation needs to be added for that, and that compensation is done by compensators. So there are different kind of compensators, like we'll be learning about the lead compensator, then we'll be having the lag compensator, then we'll be having a combination of lead lag, lag lead. So I hope I'm very clear with this. So first one is the lead compensator. The lead compensator has this input voltage Vi. That is a combination of R1 C1. There's a resistor R2. So there's a transfer function. The transfer function for this lead compensator is nothing else than V out upon V in is equal to 1 plus S tau upon 1 plus alpha S tau. So my S is the Laplace domain value, that is j omega. My tau is the time constant, which is equal to R1 into C1. Then we have the alpha. The alpha stands for R2 upon R1 plus R2. I hope I am very clear with this. The transfer function basically is 1 plus S tau upon 1 plus alpha S tau. The tau stands for R1 into C1 and the alpha stands for R2 upon R1 plus R2, which value is less than 1. This entire lead compensator acts like a high pass filter, and this is the pole zero concept of the lead compensator, wherein you have a zero and a pole. The zero is nothing else than minus 1 by tau, right? If you do 1 plus S tau is equal to 0, the S value will be minus 1 by tau, which is over here. And the pole is given as minus 1 upon alpha tau. So this is the lead compensator. What is the phase angle of a lead compensator? These are all theoretical things. These notes are uploaded in the description box of this video also. You can go and download it from there. So it is sine inverse of 1 minus alpha upon 1 plus alpha. The omega m is given as square root of omega 1 upon omega 2, and you can solve it further. So what are the disadvantages? As I said you, it's a high pass filter. So basically noise can get introduced at this particular high pass frequency. Secondly, the advantages are it helps in transient response and it is like a RC differentiator circuit. So this is all about compensator, the lead compensator. Then you have the lag compensator, which is acting like a RC integrator. So what happens in this case is that you have the input voltage Vi, you have the output voltage V0. In this case, the transfer function, which is given as V0 upon Vi as 1 plus S tau upon 1 plus beta S tau. The tau is given as R2 into C2. The beta is given as R1 plus R2 upon R2, and this beta is greater than 1. So if you have this pole 0 plot, which is mentioned over here, the pole 0 plot basically has the pole. So if you see in case of your lead compensator, we had 0 in the pole, but in case of your lag compensator, we have the pole and the 0. So obviously the pole is given as minus 1 upon beta tau. If you just equate the denominator to 0, you will get pole as minus 1 upon beta tau and the 0 as minus 1 by tau. The phase angle is given as sine inverse of beta minus 1 upon beta plus 1. Omega is given over here. So what are the advantages of a lag compensator? It's a low pass filter, right? In case of your lead compensator, it was a high pass filter, hence noise was getting introduced over here. But in case of your lag compensator, it is a low pass filter, hence noise gets discarded, and it is good for steady state response. So these are the key points. In lead compensator, there is a dominant 0, right? If you see in case of your lead compensator, I have a 0 and a pole. Whereas in case of your lag compensator, we have a dominant pole. If you see a pole 0 diagram of a lag compensator, we have a pole and a 0. So the lead compensator, settling time reduces and stability increases. In lag compensator, the settling time increases. Of course, it's taking more settling time, the stability will decrease. These are the formulas for the lead lag lead compensators given over here. You can just know the formulas, and the diagrams come here. As I told, it's a lead lag compensator, so it have lead 0 pole, and for lag pole 0. Similarly, for lag lead, the lag comes first, you have pole 0, and lead comes afterwards, you have a 0 and a pole. Similarly, we have something called as the controllers. So as I told you, when you need to redesign the system in order to compensate for certain performance, we add compensators. Similarly, controller is a mechanism that seeks to minimize the difference between the actual value and the desired value. So the controller will seek that difference to minimize the difference between the actual and the desired value. So you have the proportional controller, then the proportional integral, proportional derivative, and proportional integral derivative. The transfer functions are given over here, the effects are given over here, so you can go through them. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. The links are given down in the description box. Also, these notes are uploaded in form of a Google Drive link in my description video as well, so you can please download it from there. Please share it to as many people as you can whom you feel this particular video can be important. Thank you so much, guys. God bless.